Okay, please take a moment and read through problem number 5. If you took Pre-Calc CP2 last year, you definitely saw a lot of problems like this in the beginning of the year. We're going to take a rectangular sheet of cardboard. Okay. And this is 17 inches by 12 inches. I want to cut squares from each corner, fold up the sides, and it's going to give me a box. Okay, well, there's one, there's another, there's another, there's another. Can you picture what this is going to look like? Well, here's a piece of cardboard. I cut my squares out of the corners. I can fold up my sides, and it makes a nice little box. What's the volume of a box? Well, V equals L WH, length times width times height. What is the length of the box? Well, for this box over here, what is this length over here? I had my entire sheet of cardboard, but the length is not going to be that 17 inches. The point is, my squares, I'm going to say, have a dimension x over there. And I think the length of my box is going to match up with this length right over here. And that's just going to be 17 minus 2x. The width of my box? Well, let's see. What is this width over here? What is this dimension over here? What is that dimension going to be? The entire side was 12. I'm taking away x and another x. My width is going to be 12 minus 2x. Any idea what the height of the box is going to be? I think my height just going to be x. Basically, however much of the square we cut out, that's how high this box is going to go when we fold things up. This was my primary equation. These are my secondary equations. I can get V equals 17 minus 2x times 12 minus 2x times x. Take a moment, multiply this thing out. Let's get this thing in standard form. Let's see, I'll move the x out front. 17 times 12 is 204. Minus 24 minus 34 is minus 58x. Plus 4x squared. V equals 204x minus 58x squared plus 4x cubed. As for my domain, I know that x can't be negative. X has to be something greater than, we'll say, or equal to 0. But I think if x gets to be too big, well, then these squares are going to take up the whole thing, and I'm going to have no other dimension. The point is, I think the biggest x could be is 6, because if I cut a square with a 6-inch side out of over there, and a square over here with a 6-inch side out, there'd be nothing left for our other dimension of this thing. So x is going to have to be between 0 and 6. Next, find the derivative. Take a moment, get that derivative. V prime is going to equal 204 minus 116x plus 12x squared. It's a quadratic equation that I'm not going to be able to factor. We're going to go to the calculator at this point, and we're just going to use the quadratic formula. Take a moment and get your critical values. I'm going to set this equal to 0. 12x squared minus 116x plus 204 equals 0. Either write out the quadratic formula or use the program on the calculator. But you're going to get x is about 2.311209 or 7.3555457. And I'm going to give a lot of places here. Remember, our rule is always final answer needs to be accurate to 3 places. But because I'm going to be plugging things in then to find the volume and the dimensions and all that, I should probably give more places over here. I actually don't care about one of these. This is bigger than 6, which means my box is not possible. So I only have one critical value I'm going to care about. We now need to go and set up our candidates test, which we can do because we have a closed interval over there. Find the volume for those 3 x values. And you know what? I'm going to cheat. 0, 0. Tell me what the volume is when x equals 2.311209. Well, I'm going to go plug in 204 times 2.311209 minus 58 times 2.311209 squared plus 4 times 2.311209 cubed. That's going to give me about 211.052. And that's clearly my maximum. My maximum volume is 211.052 inches cubed. There were other things I was asked, though. Find the length of a side of the square that's being cut out. Well, that's just x. Length of a side of the square is, I think that's 2.311209 inches. We're finally asked to find all the dimensions of the box. Well, I know that's 2.311 inches by, let's do 17 minus 2 times all that. And let's also do 12 minus 2 times that x value. Finish that off in the calculator and get some dimensions. That should give us 12.378 inches, 7.378 inches. These are the dimensions of that box that we've created by cutting squares out of the corners.